So we've started chapter 4. What is a selection? It's the diamond in our flowcharts. It's our if statements. When the statement is evaluated, it produces either a true or false. Is age greater than 17, right? Well, if the grade is greater, if the age is greater than 17, then it results in a yes. It results in a true, which the computer actually underneath it all counts as a 1. If the age is not greater than 18, then it's treated as a false. A no. Computer treats it like a 0 underneath. And so that's used in every selection structure. This is a dual alternative selection, meaning it has an if and an else, right? If grade greater than 90, print A, else print, sorry, you didn't make an A. A single alternative, that's something or nothing, so there's no else. If grade greater than 90, print, yay, you made an A, go celebrate. Otherwise, we're not going to tell them anything. And why don't we just have a huge flowchart here that we're going to ignore? All right, we'll zoom in on part of it.
So that program was written by more than one person?
Yeah, it could have been if it had more modules. I don't see many modules. I see a housekeeping module and a finish, but yeah, it could have been broken up. I'm not having y'all break out a section called housekeeping. I don't really think it works for the language that we're using for our style of programming. But housekeeping is just all the stuff that happens at the top. You're going to open a file and you're going to declare some variables, whatever. So this is a payroll program calculating overtime. Is the hours greater than the work week? If so, calculate it via this long expression. Otherwise, if the hours is not greater than the work week, if hours is not greater than 40, we calculate it with a short expression. Now this is different than how I had us calculate our pay, but the result is the same. We can always have a 10-minute discussion about it. I think we already had that. Maybe not in this class. You know, because people think about how overtime is calculated differently. And I show them one way and they know it the other, and so we have a discussion about it. Finally, I convince them, and I tell them that it could be done either way. All right, so this is a dual alternative based on whether the hours, whether they earned overtime or not. Why don't I like this particular way of doing it so much? I'd rather calculate the bonus separately so that down here when we're printing our answers, when we're printing our solution, we can tell them, right? Your base pay was, $1,000, and then you earned, $100 of overtime. I'd like to see that. I'd like to understand why I earned $1,100 to make me feel better that the calculation was done correctly. Because do we trust our employers? All right. So there's the if-then. Well, we don't have the word then in our language, but that's what it's called in textbooks. If, then, else. It's really if, else. So the clause is the stuff that goes after the if statement. If age greater than 17. That's the clause. I would call it the logical expression. Guess we could type some notes in, but I'm not going to require them. I'm not going to do mandatory. I know some people like notes. So, all right. So, we are talking about making decisions. We have ifs. The thing after the if is the clause, which is a logical expression. So if we have if age greater than 17, age greater than 17 is the clause expression. Age greater than 17 is evaluated to produce a true or false value. then statements are executed based on that. I'm just going to make it decides what to do next. So we have single alternatives, which is just if. If something, do something. Then we have dual alternative. If something, do something, else do something else. You can see why it's called dual alternative. Textbook calls this if then else. Even though we don't have a then keyword, that's what they call it. This is the then part, right? I even said that when I was reading aloud. If something, then do something. Else, do something else. So the else clause is what gets done if the expression evaluates to false, right? So whatever, right? I'm going to say condition. I changed that word to condition just to be a little more precise, be textbook precise. So relational comparisons. Is something greater than something? Is something less than something? So there are relational operators, which means stuff like less than, greater than, equals, right? Stuff like that. Well, we're going to list all 6 of them. That's a less than. That's a greater than. We know this. This is a less than or equal to. That's a greater than or equal. Two equal signs means is equal to. Or just shorten it to say equals. And then exclamation mark means not equal to. One of y'all had a really good way of putting that, and I don't remember it now. Get a way of phrasing it. Don't remember. So when you're wording expressions, you have to be careful of the opposites. Equal, equal, and not equal are pretty clearly opposites. So equal, equal, not equal. Those are opposites of each other. Now the way our brains work, we want to say that less than and greater than are opposites, but that's not true. The opposite of less than is greater than or equal to. I could give y'all a lecture on why, or maybe you just want to accept it. And the opposite of greater than is less than or equal to. Maybe I'll show you why. If A greater than 10, print yes, else print no. If we wanted to swap the logic, we could do that. If A less than 10, I'm going to write it wrong. We're going to have to revise it. Print no. Else print yes. Yeah. It should do the same thing. It should still print yes if it's larger than 10, and it should still print no if it's not. The problem is what if x is exactly equal to 10? Considering these 4 lines of code, if x is equal to 10, is it going to print yes or no? Well, is 10 greater than 10? Is that a true-false statement? 10 is greater than 10. I've heard one person say, I want a resounding chorus. Is 10 greater than 10?
No.
No. Okay. So it's not going to print yes, it's going to print no. All right. Is 10 less than 10? No. Okay. So it prints yes. It behaved differently because we didn't flip the logic correctly. To handle the condition where the two values are the same, you have to make it less than or equal to. Now,
So it's a logic error.
yeah, that would have been a logic error. That's correct. So, if you were taking notes and typing exactly what I typed, better do that. They call the single equal sign the equivalence operator. However, we've learned that it's actually double equals. I don't know of any language that uses single equal to test for equality. And we know what greater than means, and we know what less than means. We know what greater than or equal means. We know what less than or equal means. And here's a big mistake. That is not the not equal to operator in every language I've ever used. It's that. So, thanks textbook. But it's written to cover multiple languages. The problem is just that in every single language I've ever used, it's that. Sure. Less than greater than is what we learned, you know, in grade school, junior high, high school, whatever. So any kind of decision could be made with these types of operators, these comparisons.
There it is again.
Yep. So if you're doing not equal to, the thought process involved gets a little bit more complicated. The more nots you throw in to your logical expression, the harder it is to think about.
Didn't we have that on the test?
I think so.
Because I asked about it.
Yeah, so if you have something like, or if I say, I ain't not going to the store, you have no idea whether I'm going to the store or not, right? Because you don't know if I mean it as a double negative or not. If it's a double negative, it's supposed to cancel things out, and that means that I am going to the store, right? And, you know, we can usually figure things out from context, you know. But there's another word for not. I mean, another way of expressing not. Like this. You could say, if A not equal to 10, that's one way of wording it. Or you could say, if not A equal 10. Both of those are valid. The not keyword just flips the truthiness of that. So these mean the same thing. I would just word it like that, though, because by the time you throw the word not in, then your brain's going through knots trying to figure it out. But the computer knows, you know, it doesn't care which way we write it. But if I can avoid using the not keyword, then I feel a lot better about it. Try to avoid the not keyword if you can, because the expression is usually clearer without it. And if it's clear, it's easier for you to understand. It's easier for somebody else who has to come and modify your program. I think we're going to be done. And I think we've written enough if and else that I'm going to be content with not giving y'all homework. I ought to give you homework every week. But, okay, I got to give you homework because actually I'm not going to be here on Thursday. So, we got to have the homework. So, what kind of homework are we going to do based on decisions that we haven't already done? Somebody tell me if we've already done an assignment like this.
Yeah, we've already done it.
Yeah, you've already done it. No, yeah, let's find out. Okay, ask the user for a temperature. Convert it to Celsius. Then tell the user if it is a liquid or non-liquid. How do you tell that? If the temperature is greater than 0, it is a non-liquid. If the temperature is less than 0, it is a non-liquid, right? Because it's ice. Okay, this is specifically for water at standard temperature and pressure, right? But let's roll with it. Okay, that was not supposed to be greater than 0. That was supposed to be greater than 100. Because boiling point in Celsius is 100, freezing point in Celsius is 0. So it's steam if it's greater than 100, it's ice if it's less than 0. That's why those two values, that's why Celsius is the weird thing that it is to our American eyes and ears, is because it was written with that in mind. Someone decided that the most important thing in the world was the temperatures of ice and of boiling, and they based the temperature scale based on that. I don't know where Fahrenheit came from, how that was calculated. Who created that? Well, probably Mr. Fahrenheit. I don't know. Alrighty, I know that we've done something with logic similar to that. I just didn't ask you to convert it to Celsius first. So I'm going to remind you the equation for Celsius. Celsius is equal to Fahrenheit minus 32 in parentheses divided by 1.8. That's the equation you're going to use. So there's two ways that you could solve this. One is you could print out that it's steam, liquid, or ice, or you could just follow my instructions exactly and say liquid or non-liquid. I'm happy with either way. So I'm not going to be picky. I'm not going to give you more instructions than that. And I'm not going to give you a flow chart because this is conceptually not too difficult. So reminder, no class on Thursday. Y'all are several days ahead of the other class. This will winnow that down. That's not why I'm doing it. I apologize. I have hospital appointments that day. Doctors set the times when I come, not me. So why don't we call ourselves done? Make a Dropbox for this. If you didn't take any notes, that's okay. Just upload something saying you were here. At the end of the semester, I usually grade by calculating two averages. One is where everything is worth a third, and then the other is based entirely on your homework and your tests and exams, leaving out the lectures. So if you've been forgetting to upload lectures, then that might not kill your total grade. But on the other hand, you're getting free points just for showing up, right? A third of your grade is based upon showing to every lecture and uploading something, so that helps your grade. So it's well worth doing. Pardon me? Yeah, this is going to be lecture M. I just haven't made it yet. Sorry, I was blathering too much. Let's do that. Come on. I said new folder. Yeah. All right. Lecture M is there. And I am pleased with the exam scores, y'all. So as a whole, y'all did real well. I'm pretty happy. All right.